Okay, overview of how a N-phase microinverter system is wired here in Austin Energy's service territory. We'll start at the roof. So if you look up, the solar panels are on the roof with the microinverters. This conduit coming down is 3 3/4 inch EMT. It's strapped to the wall every 10 feet. And it's strapped before it enters what's called an electrical gearbox 3 feet before it enters. So those are two things to keep an eye out for. It comes into this panel here, which is, it's a breaker sub panel, 60 amp. And what we're doing in this one, it's called an inverter aggregate panel. So we're taking the two circuits of N-phase microinverters and combining them into one circuit. The other breaker here, it's labeled LA, is called a lightning arrestor. It's this right here, protecting the equipment against a lightning surge. So again, two branch circuits of N-phase microinverters come down, get tied into these breakers. One circuit comes out, and that comes out this pipe up into the photovoltaic system AC disconnect. Inside this, you'll see the wires go up into these terminal lugs. This is a fused AC disconnect. The reason it's fused is because of the way we connect it into the main breaker panel. So wires come up through the fuses, which are protecting all the wires from overcurrent. It's called an overcurrent protection device. Every system must have an overcurrent protection device, whether it's the fuses in the disconnect or a breaker in the main panel. So after the fuses, we go the wires out into the PV meter. This is not required in all jurisdictions, but in Austin Energy service territory, must have a PV meter. One thing to look out for is with the PV meter, as the electricity is coming off the roof down through the aggregate panel up through the AC disconnect, the wires must first go into the top lugs of the PV meter, and then down and out the bottom lugs into the panel. The reason is because when they put that meter in, it's measuring solar production. And when the energy comes in through the top lugs and out the bottom lugs, it's going to spin the meter forward. We've had instances with installers who wire this backwards. Well, they'll come through the AC disconnect and wire the bottom lugs first and then the top lugs and out. And that'll actually spin the meter the wrong way. So that's one thing to keep an eye out for when you do a pre-inspection. Make sure it's coming into the top lugs, then down out the bottom lugs into the panel. In this case, we've got a very old breaker panel, so we didn't want to interconnect using a breaker. So what we did was we used what's called a hot tap. And basically, if you can come get a close-up, you'll see our solar wires coming out of this conduit up into the panel, and we've got the two hot tap splices on the main feeders up there. So that's our point of interconnection into the electrical infrastructure of the home. And so the PV meter is only going to spin forwards, but as the energy flows, it'll go into those wires. If the energy is needed in the house, it'll feed the home. If it's not needed in the house, it'll actually back feed through the main feeder wires out through the main billing meter. This is called a billing meter. And then out onto the grid. The billing meter registers three things. One is delivered energy, how much energy the grid is delivering to the home. Received energy, which is how much energy the solar PV system exported onto the grid. And net energy, which is the difference between the two.